Bismillah, alhamdulillah, wassalatu wassalamu ala rasulillah. This is the second point in section 7.3, and it's about the product rule. We discussed the definition of the conditional probability or the formula with probability of A given B equals probability of A intersection B over probability of B. Now, if we multiply cross product, this is over 1, multiply, then we get that the probability of A intersection B is equal to probability of B times the probability of A given B. Notice that if you write probability of B, then here it's a conditional probability and B is the condition, okay? Given is the given information. So it's probability of B times probability of A given B. Also notice that probability of B given A will be probability of B intersection A over probability of A because A is the condition. We always divide by probability of the condition. And probability of B intersection A is equal to probability of A intersection B. So also here, if we multiply cross product, we get that probability of A intersection B, this time probability of A times probability of B given A. So in fact, probability of A intersection B can be written as either this one or this one. So you can write probability of A intersection B equals to probability of A times, but then it has to be B given A, or you start with B and then you have to multiply by A given B. So what you start with here would be the condition here, okay? This is to help you remembering the formula. So this is the general formula for the intersection. And because we are multiplying, we call it the product rule. So that's called the product rule. Suppose that so whenever he asks about and intersection, you understand that it is product. Suppose that from a deck of 52 cards, 2 cards are drawn. Notice now we are drawing 2 cards, not 1 card, without replacement. Without replacement, as we discussed in the previous video, we will not put the first card back. So in the second time, in the second drawn, the number of cards would be 51, not 52. Find the probability that both cards are kings. So both cards are kings means what? Means king at the first. Okay, the first card is king. First card is king. And, okay, and, or intersection, or and. Second card is also king. So and, how do you find the probability of and? Well, we start either by what do we know? Which probability we know? Do we know the probability of the first card being a king or the second card? Of course, we know the probability of the first card. So this would be equal to probability. Let me call this probability E, and this is F. So I need to find probability of E and F or intersection F. By definition, this would be probability of E times probability of what? F given E. Okay, if you start with E, here F given E. So E is first is king. What is the probability that the first card is king? How many kings are there? 4. How many cards are there? 52. Now, what is the probability of second is king, given that the first is king? Because I need the probability that both cards are kings. So I need the probability that the second is king, given that the first is also king. How many cards do we have now without replacements? We have 51 because one king is being selected. How many kings are there left? Okay, there are four in the beginning, but I selected one here. So I still have 3 kings. So this would be the answer. This is the probability that both cards are kings. we can use tree diagram. Okay, the first card selected could be a king or not king. 4 over 52 the probability of king, 48 over 52 probability of not king. The second card, now without replacement, so the second card, the number of cards would be 51. And now the probability of selecting king in the second, given that king in the first, would be what? 3 over 51, because 3 kings left. But the probability of selecting not king in the second, given that king in the first, would be 48 over 51, because I selected one king. So also always the probabilities here, these probabilities, these four probabilities are given probabilities. So 3 over 51 is probability of king in the second given king in the first. This 48 over 51 is the probability of not king in the second given king in the first. So all of these are conditional. This one, probability of king in the second given not king in the first, and so on. So this is what he says here. The probability attached to each branch is the conditional probability that the specified event will occur given that the events on the preceding branches have occurred. So this is the probability that k in the second given that k in the first. So he was asking here about what? About and. So how do you find and from a tree diagram like this? Well, when an event can be described by one path means kk, k and k. Okay, so he said what? He said first is a king and the second is a king. So first is king, this is the first, and second is king. So this is one path. He needs king, king. So this event, how to find its probability? The probability that the event will occur is the product of the probabilities on the branches along the path. So the probability of king, king would be, so probability of k given k is 3 over 51. But probability of k and k not given would be 4 over 52 times 3 over 51. So you need to distinguish between these two kinds of probabilities, all taken from the probability tree. Okay, so for example, not k, not king, given not king is what? Is 47 over 51. But probability of not king and, you write it and, or you write it as uh, intersection, would be what? Would be this path. Okay, you multiply. So 48 over 52 times 47 over 51. I hope it's clear for you. A box contains 3 black balls, 2 red balls, 5 white balls. One ball is drawn, it is not replaced, and the second ball is drawn. So we will draw 2 balls and without replacements. Find the probability that the first ball is red and the second ball is black. He is asking about branch here. Let me do the tree diagram for this experiment. Think of the first ball. What are the choices for the first ball? Well, it could be black, it could be red, or white. What is the probability that the first ball is black? How many blacks? 3. The total number of balls, 3 plus 2 plus 5 is 10. What is the probability that the first ball is red? 2 over 10. The probability that the first ball is white, 5 over 10. Now let us select another ball. So we have 3 branches. Again, the second ball could be black, red, or white. Here also, I could have the second ball black, red, or white, and also black, red, or white. And all of the probabilities now, which I'm going to write, are conditional probabilities. These in the black, conditional probabilities. So what is the probability that the second ball, the experiment is without replacement? So the number of balls now is not 10 anymore, it is 9. And here we selected black. So the number of blacks is 2 over 9. The number of red is as it is, the number of white as it is. So the total number, if you add these probabilities, you will get always 1. Here, red is selected, so one red has gone. So I have 1 over 10 probability of red, but black would be 3 over 9. Sorry, it's not 10, it's 9 because we still have only 9 balls. And here, white, how many whites are there? 5 over 9. Well, here I selected one white in the first, so the number of white balls would be 4, but the number of red as it is and the black as it is. So this is the tree diagram. Now he is asking about what? Probability that what first ball is red, second ball is red. So RR, where is RR? This is RR. It's the path, and the probability would be 2 over 10 times 1 over 9. And you can think of it without a tree diagram, similar to the way I solved this problem, this example. Two balls are drawn without replacement from the box described in example 4. So this example, okay, find the probability that both balls are white. So he needs white, 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 white. So WW, what would be the probability? 5 over 10 times 4 over 9. So probability of white and white would be 5 over 10 times 4 over 9. All right. Find the probability that the first ball is white and the second ball is red. Well, the first is white and the second is red. And so white and red. So 5 over 10 times 2 over 9. Now, okay, let me add a point. What if the question, let me ask one question. What is the probability that one ball is red, for example? Okay, what is the probability that one ball is red? If I want to find the probability that one ball is red, how to answer this question? Well, uh, one one ball, let me say exactly, okay, exactly. I mean, it cannot be two balls. So only one ball is red. So a red ball could come from BR. So this would be probability of B and R, or or so plus. Also from here, R and B. Also it could be R and white, the first red and the second white. Or it could be white and R. So here there are 4 possibilities. The second ball is red and the first is black, or the first is white. The first is red and the second is black, or the second is white, if he needs exactly one. And I add all of these probabilities. So B intersection R is 3 over 10 times 2 over 9. R intersection B is 2 over 10 times 3 over 9. R intersection W is 2 over 10 times 5 over 9. W intersection R is 5 over 10 times 2 over 9. And I add all of these, and this would be the probability that one ball is red. So having the probability tree, you can answer even more and more questions. Two balls are drawn from a bag containing 3 white balls, 2 red balls. If the first ball is replaced, before the second is drawn. Now we are replacing. When you replace the ball, you put it back. So the number of balls will not change. What is the probability that both balls are red? So what is the probability that the first ball is red? So red intersection red, or red and red. Okay, red and red and. So probability that the first is red. How many red balls are there? 2 out of what? Out of 5 times. What is the probability that the second is red, given that the first is red? Well, it's still 2 over 5, because even if the first is red, we will put the ball back, isn't it? So it doesn't really matter here, because the experiment is with the replacement. It doesn't really matter uh, to look at the first ball. Okay, the probability of the second ball is always being red, always 2 over 5. Both balls are white, 3 white balls. So the probability of white and white is 3 over 5 times 3 over 5. Okay. The first ball is red and the second is white. So probability of red and white. Well, red, probability of red is 2 over 5. Probability of white is 3 over 5, because the experiment is with replacement. One of the balls is black. Do we have black balls? Oh, there are no black balls. So the probability of black, one is black, is 0, because there are no black balls. Okay, so this is an impossible event. So what if you want to make a tree diagram here? Well, a tree diagram would be easy. The first ball could be white or red. Probability that it is white, 3 over 5. Probability that it is red, 2 over 5. Now the second ball could be also white and red. And now the probability that it is red is also 3 over 5, 2 over 5, because the ball is replaced. So always here, the probability of white would be 3 over 5, and the probability of red would be 2 over 5 in each time we draw a ball, even if we draw more than 2 balls, if we select more than 2 balls. A red ball and 4 white balls are in a box. Okay. If 2 balls are drawn without replacement, so we are not going to put it back, what is the probability of getting red ball on the first and white ball in the second? So probability of red on the first and white on the second. What is the probability of red? How many reds are there? A red ball, 1 red. Okay. And 4 white. So how many balls? 4 plus 1, 5. So probability that the first ball is a red, 1 over 5 times. Now the second time, how many balls are there? 4, not 5, because we took 1 red. So the second is a white. How many white balls are there? 4. So if we draw, if we select, if the first ball is red, then the second ball has to be white, because we still have 4 out of 4. Okay, so the probability would be 1 over 5. Getting 2 white balls. 2 white balls, probability of white and white. How many white balls? 4 out of 5. This is the probability of the first being white. Now the second being white, I still have 4, but 3 only of them are white. So the answer is 12 over 20, or 3 over 5. 2 red balls. So probability of red and red. Well, this is impossible. Okay, because I have only 1 red ball. I cannot get 2 red balls. So you can find the probability that the first is red. It is 1 over 5. But the probability that the second is red is 0. So the probability would be 0. All products on an assembly line must pass two inspections. It has been determined that the probability that the first inspector will miss a defective item is 0.09. If we draw a tree diagram, now this is the first inspector, and let us say probability of missing a defective and not missing a defective. So probability of missing a defective from the first inspector is 0.09. Not missing would be 0.91 because it is 1 minus 0.09. Okay, this is the first inspector. Now what would happen? If a defective item gets past the first inspector, there will be a second inspector. And there is a probability that the second inspector miss or not miss. The probability that the second inspector will not detect, so missing, is 0.01, and 0.99 he is not going to miss. Okay, what is the probability that he did not say anything about this one? Okay, what is the probability that a defective item will not be rejected by either inspectors? Will not be rejected means missed. He will be missed. So the probability that the first inspector misses and the second inspector misses. So this is, and it is 0.09 times 0.01. So that's the probability. A company estimates that 30% of the country has seen its commercial. Okay, so if we call this C, commercial, probability of seeing the commercial is 0.3, 30%. Okay, and that if person sees its commercial, okay, if means conditional. If a person sees its commercial, يعني given that C, if a person sees the commercial, there is a 20% probability that the person will buy its product. So if we call buy B, so the probability that he buys the product, given that the person sees the commercial, is 0.2. What is the probability that the person chosen at random in the country will have seen the commercial and bought the product? So he is asking about seeing the commercial and bought the product. So the probability is probability of either C times B given C or B times C given B. This is the definition of the product rule. Which one do we have? Do we have in the question PC or PB? We have PC. Okay. So this one is not used here because we have PC, it is 0.3, and we have probability of B given C, which is 0.2. So the answer is, the probability is 0.06. That's it. I'll stop here and I'll continue independent events in the next section.